Okay, here we are. We're doing 5-8 today, solving radical equations and inequalities. And the joke is, teacher says, your behavior reminds me of the square root of 2. Why? Because it's completely irrational. Some vocab. A radical equation is an equation that has a variable. In this case, we're going to be using x as our variable a lot, underneath a radical. So that would be something like square root of x or square root of x plus 2. In this case, the variable is underneath the radical. And then a radical inequality. We're going to be talking about that. So, this one, right off the bat, wants us to solve each equation. These are radical equations. So I'm just going to do this simply algebraically. This one is 2 times the square root of x plus 1 equals 14. So right off the bat, using simple algebra, I can divide both sides by 2. That gets rid of that. Divide by 2. Notice the 2 is on the outside of the radical, therefore I can just cross it off easily. There's a plus 1 here. I can't just subtract 1 from both sides and expect to get rid of it because that is underneath the radical. So we've got to take care of this stuff outside of the radical. And now I have square root of x plus 1 equals 7. And now to get rid of the radical, this is the square root of x plus 1. So what I can do is square both sides. So I'm going to take this, raise it to the power of 2. Take this 7. You don't need to put parentheses around it if you don't want to. Raise it to the power of 2, and that gets rid of my radical. And we have x plus 1 equals 7 squared, which is 49. Subtract 1 from both sides, and I get x equals 48. And what I can do is I can plug this value back in for x to check, and I'll go ahead and do that over here in red, and then I'll erase it so I have room. But I can plug in 48 for my x plus 1 equals 14. So 48 plus 1 is 49, and the square root of 49 is going to be 7. 2 times 7 is 14. 14 equals 14. So my answer 48 definitely works. Okay, second one. I've got 5 times the cube root this time of 4x plus 3 equals 15. Once again, I'm going to take care of the stuff outside of the radical first, so I'm going to divide both sides by 5, and we'll get rid of this. That makes this a 3, so now I've got the cube root of 4x plus 3 equals 3. And now to get rid of this radical, I want to raise both sides to the power of 3. So I'm going to cube both sides. Okay, so that gets rid of this radical, and I'm left with 4x plus 3 equals 3 cubed is 27. Going to subtract 3 from both sides. We get 4x equals 24. Divide both sides by 4, and I get x equals 6. And I could plug that back in to check and make sure, but I'll let you do that on your own. Okay, so these ones are for you to try by yourself, and I will go ahead and do them now. So I've got 4, I'll rewrite this, 4 plus the square root of x minus 1 equals 5. So once again, I'm going to take care of the stuff outside of the radical first. So I'm going to subtract 4 from both sides, and I get the square root of x minus 1 equals 1. And then I'm going to square both sides to get rid of that radical, and we get x minus 1 equals 1 again. Add 1 to both sides, and I get x equals 2. And if I want to check that, I can do that really quick. Actually, we have 4 plus the square root of 2, because I'm plugging that in for x, minus 1 equals 5. That becomes 4 plus 2 minus 1 is 1. Square root of 1 is 1, so 4 plus 1 equals 5. So yep, that does work. Very cool. Okay, this one, I'll rewrite it. We've got the cube root of 3x minus 4 equals, what does it equal? It equals 2. So since it's the cube root, there's nothing outside of the radical that I have to worry about. I can go ahead and get rid of it right off the bat by cubing both sides. So I'm going to take both sides and raise it to the power of 3, and that'll get rid of this radical. So now I have 3x minus 4 equals 2 cubed. What's 2 cubed? 2 times 2 is 4. 4 times 2 is 8. So we get 8. Now I'm going to add 4 to both sides. We have 3x equals 12. Divide both sides by 3. And we have x equals 4. Boom. Okay, last one. We've got 6 times the square root of x plus 10 equals 42. So I've got this 6 on the outside of my radical, so I want to deal with that first. So I'm going to divide both sides by 6. And I have the square root of x plus 10 equals, what's 42 divided by 6? 7 is what that is. And then to get rid of this radical, I'm going to square both sides. That gets rid of the radical. I have x plus 10 equals 7 squared is 49. Subtract 10 from both sides, and I have x equals 39. And that would be a fun one to plug back in and check. Let's think about it. If we plug 39 back in for this x, under the radical we have 39 plus 10, which is 49. And we know that the square root of 49 is 7. 7 times 6 is 42, so it works. Okay. Now this is about solving equations that have 2 radicals. So there's a radical over here and a radical over here. So I'll rewrite this, and we've got the square root of 35x equals 5 times the square root of x plus 2. Now normally I would tell you to get rid of, or to deal with, rather, the stuff outside of the radical first. But that wouldn't really do anything helpful for us, because if I divided both sides by 5, I would just have a radical divided by 5. So what I'm going to do is get rid of the radical first in this case. So I'm going to square both sides. If I do it to one side, I have to do it to all of the other side. So I'm going to take this whole thing and square it, take this whole thing and square it. That gets rid of this radical, so I just have 35x. And then 5 squared is 25, so that's what that is, 25. And then the square root of x plus 2 squared is simply x plus 2. It just gets rid of the radical. So it's 25 times x plus 2. Okay, now I can go ahead and distribute this 25, so I have 35x equals 25x plus 50. And then I'm going to subtract 25x, right, because I'm combining like terms, so I can subtract 25x. And this becomes 10x equals 50. Divide both sides by 10, and I have x equals 5. Okay, and you know what? Let's go ahead and plug this one back in. Let's go ahead and do that. So I got my 5. I'm going to plug it back in. Hopefully I have enough room on this side to do this. And we've got the square root of 35 times 5 equals, looks like I don't have enough room. Okay. I'm going to make a mess of this. If you need it, you can pause it and go back. Okay, so we've got the square root of 35 times 5 equals 5 times the square root of 5 plus 2. Okay, 35 times 5 is going to be this big number that I don't really want to deal with because it probably won't square nicely anyway. So what I can do is I can factor this down. 35 can factor into a 7 and a 5. So now I essentially have the square root of 7 times 5 times 5. Now you notice that I have two 5's here and I have the square root of two 5's, so that means I can take one 5 out. So this is going to be 5 on the outside of the radical times the square root of 7 equals 5. Now what's 5 plus 2? 7. And that's on the inside of my radical. So I've got 5 times the square root of 7 equals 5 times the square root of 7. Those are equal to each other, so I know that x equals 5 works. These are for you to try by yourself. Got a lot of stuff moving upstairs. Okay, hopefully you did that. So the first thing I'm going to do is square both sides. So I've got square root of 8x plus 6. I'm going to go ahead and square that to get rid of the radical. And then I've got 3 times the square root of x. I'm going to go ahead and square that whole thing. So that gets rid of this radical. And I have 8x plus 6 equals 3 squared is 9. Square root of x squared is just x. So that's going to be 9x. Now I want to combine like terms, so I'm going to subtract this 8x from both sides, and I get 6 equals x, x equals 6. 6 equals x equals 6. We're all happy. Okay. All right. This one, we've got the cube root of x plus 6 equals 2 times the cube root of x minus 1. So what I want to do is get rid of those radicals. This time it's the cube root, so instead of squaring both sides, I'm going to cube both sides. So I'm going to raise that to the power of 3, raise this to the power of 3. That gets rid of this radical, so I have x plus 6 equals, what's 2 cubed? We already talked about that earlier. That's going to be 8. Cube root of x minus 1 cubed is just going to be x minus 1. So then I'll distribute my 8. I've got x plus 6 equals 8x minus 8. And now I want to combine like terms, so I'll subtract my x. Subtract my x, I get 6 equals 7x minus 8. And then I want to add 8 to both sides. 8 plus 6 is 14 equals 7x. Divide both sides by 7. That's not a 7, that's an x. Divide by both sides by 7, I get x equals 2. And you can check that by yourself if you want to. Woo! Getting tired. Okay. Solving equations with extraneous solutions. Extraneous solutions. Those are solutions that don't work. So, what I'm going to do first is I'll show you what this looks like with the graph. This is the square root of x plus 8 equals x minus 2. So what I'm going to do is I'm going to graph this, and I'm going to graph this on y1 and y2. So in y1 I've got the square root of x plus 18, and in y2 I've got x minus 2, and you can see there's the square root of x plus 18, and then this straight one is x minus 2. And you can see that these graphs, they only intersect at one point. They only intersect at one point. And if you don't believe me, I can zoom out. just to get a bigger picture. There's my radical function and there's my linear function, and they only intersect at one point. So that means if we get two solutions, which spoiler alert we will, one of them is going to be extraneous. Okay, one of them's not gonna matter because they only are equal to each other at one point. So let's solve this. Enough yapping. We've got the square root of x plus 18 equals x minus 2. To get rid of these radicals, I'm going to square both of these. Now I have x plus 18 equals, now I've got x minus 2 squared. So I have to FOIL this, right? Because it's x minus 2 times x minus 2. And I get x squared minus 4x plus 4. Okay? Now what I'm going to do is combine like terms, setting everything equal to 0. So I'm going to subtract x from both sides. I'm going to subtract 18 from both sides. And I get 0 equals x squared minus 5x minus 14. Now I got to factor this. So we get 0 equals, I need two factors of 14 that are going to equal negative 5. So let's go with negative 7 and positive 2. So now, if I solve for x, x is going to equal negative 2 and positive 7. Now, what I want to do is plug these back in and check to see if one or both of them are extraneous. And we already know that one of them is. So let's see which one that is. First of all, I'm going to plug negative 2 back in to my original equation. So over here, this is where I'm checking. Check. So I've got the square root, the square root of negative 2 plus 18 equals negative 2 minus 2. Negative 2 plus 18 is 16, so square root of 16 equals negative 4. Square root of 16 is positive 4. Positive 4 does not equal negative 4, so this is a big red X. When I plugged in negative 2, that one does not work. Let's try 7, okay? So I've got the square root of 7 plus 18 equals 7 minus 2. 7 plus 18 is 25, so that's going to be the square root of 25 equals 7 minus 2 is 5. 5 equals 5. Yes, it does, so this is going to be a check mark. Ding! So that means that my answer is then only x equals 7. Boom. Because x equals negative 2 was extraneous. All right, these lovely problems are for you to do by yourself. And let's get to it. So this is the square root of 2x plus 14 equals x plus 3. So I'm going to go ahead and square both sides right off the bat. That gets rid of this radical. I have 2x. Something went wrong with my pen there. 2x plus 14 equals, now this is x plus 3 squared. So it's going to be x squared plus 6x plus 9. Now I want to combine like terms, so I'm going to subtract 2x from both sides and subtract 14 from both sides, and I have 0 equals x squared plus 4x minus 5. Then I have to factor that, so I have 0 equals x x plus 5 times x minus 1, right? Two factors of negative 5 that are going to equal 4. Does that work? Yes, it does. So then I have x equals either negative 5 or positive 1 or both. But we have to check, okay? So over here I'm going to check. This is where I'm checking to see. So let's plug in negative 5 first. So I have the square root of 2 times negative 5 plus 14 equals negative 5 plus 3. 2 times negative 5 is negative 10 plus 14 is positive 4, so that's a square root of 4 equals negative 5 plus 3 is negative 2. Square root of 4 is 2. 2 does not equal negative 2. Does not work. So that means that this one, negative 5, does not work. Okay? Let's try this next one. Let's try 1. So we have, my computer went blank. We have the square root of 2 times 1 plus 14 equals 1 plus 3. 2 times 1 is 2 plus 14 is 16, so that's a square root of 16 equals 1 plus 3 is 4. Square root of 16 is 4. 4 does equal 4. So that one, that's a check mark. Ding! That one works. So the answer is x equals 1. Okay, next one. Let me erase this. Next one, we've got the square root, we're in square roots again, of negative 9x plus 28 equals negative x plus 4. I'm going to square both sides to get rid of this radical here. Getting rid of the radical. So now I have negative 9x plus 28 equals, and I'm going to square this. So I have, in this case, I have x squared minus 8x plus 16. Combining like terms, so I'm going to add 9x to both sides. That's a plus to both sides. And then I'm going to subtract 28 from both sides. And I have 0 equals x squared plus x minus 12. So I factor that. I hope you can, I'm not in the way. I don't think I'm in the way. I factor that, and we've got x plus 4 times x minus 3. X equals negative 4 and positive 3. So now we have to check these blokes. And I don't have enough room, so I'm going to erase all this. You've been warned. I'm erasing all of this. And I'm checking over here. I'm checking over here. Okay? So this is me checking. Can you see that? I think you can. Okay. So let's try negative 4 first. So we've got the square root of negative 9 times negative 4 plus 28 equals, so this is negative x. So since my x is negative 4, this is going to be positive 4 plus 4. Okay. Negative 9 times negative 4 is a positive 36. So inside this parentheses, I've got 36 plus 28 equals 4 plus 4 is 8. Now 36 plus 28, I'm going to have to think. We've got 14, carry the 1, so that's 64. So this is the square root of 64 equals 8. Square root of 64 is 8. Boom. So that one works. Okay? Negative 4 is okay. That one works. Let's try 3 because sometimes both solutions work, and that's the truth. So let's check 3. Okay? So we're checking 3. So we've got the square root of negative 9 times 3 plus 28 equals negative 3 plus 4. Negative 9 times 3 is negative 27. So inside this parentheses, I've got negative 27 plus 28. And then here I've got negative 3 plus 4 is going to be positive 1. Negative 27 plus 28 is 1. So square root of 1 equals 1. Square root of 1 is 1 equals 1. Boom. So that one works as well. This one works as well. So our answer in green, because green's cool, is x equals both negative 4 and 3. And that, if you got lost, is for this one. Okay, that was a lot. Solving equations with rational exponents. Rational exponents. Very similar, but you have to remember that rational exponents, right? This is 3x minus 1 raised to the 1/5 equals 2. Raised to the 1/5 is another way of saying the 5th root of. Okay, the 5th root of. So this is the same thing as saying the 5th root of 3x minus 1 equals 2. And we would know how to get rid of that, right? We would raise each side by the power of 5, and that would get rid of that radical. It's the same thing when you're dealing with rational exponents. And let me show you why. It has to do with the property of exponents. So if we have this equation, 3x minus 1 raised to the 1/5, we can do the same thing that we do if it was a radical, and raise this whole thing to the power of 5. If we do it to that side, we of course have to do it to this side. And now, using the property of exponents, you've got 1/5 raised to the 5th. These two exponents multiply. They multiply. What is 1/5 times 5? It's just 1. It's 5 over 5, which equals 1. Right? 1/5 times 5, which is the same as 5 over 1. They just multiply straight across. This becomes 5. This becomes 5. 5 over 5 equals 1. So these equal 1. So they cancel out. They cancel out. So this becomes, let me get back to blue, this becomes 3x minus 1. Okay? 2 to the 5th. Maybe you want to get out your calculator for this, but take my word for it. And my notes word for it. Don't tell anybody I'm using my notes. But it is 32, I think. Find my place. I lost my place. I think it's 32. I'm going to use my calculator because it's the end of the day. Yep. 2 to the 5th is 32. So we got 3x minus 1 equals 32. I'm going to add 1 to both sides. 3x equals 33. Divide both sides by 3. X equals 11. Plug that back in to see if it works. I'm not going to do that right now, but, well, all right. If we have 11, we plug it back into this x, we get 3 times 11 equals 33, minus 1 equals 32. The 5th root of 32, we already figured out that 2 to the 5th is 32, so 32 to the 1/5 is 2. 2 equals 2, so boom, there you go. Okay, next one. Here, we've got x equals x plus 12 to the 1/2. This is raised to the 1/2, so what do we have to raise it to get rid of that? 2, okay? So I'm going to square both sides. Now I have x squared equals x plus 12. Because in squaring this, I got rid of the power of 1/2. Boom, they canceled out. They became 1. Okay, so now I'm going to subtract x and subtract 12 because I like everything on my left side. And now I've got x squared minus x minus 12 equals 0. Let's factor this. And we've got x minus 4 times x plus 3 equals 0. X equals 4. and negative 3. Now we have to check because one of these might be extraneous. So we have to make room, annoyingly so, in our notes, and check. So let's check 4. Plugging in 4. So we've got 4 equals 4 plus 12 raised to the 1/2. 4 equals, what is 4 plus 12? It is 16 raised to the 1/2. 16 raised to the 1/2 is 4. 4 equals 4, so that one works. We get a big check mark for that one. Boom. Let's try negative 3. Okay? Try negative 3. Negative 3 equals negative 3 plus 12 raised to the 1/2. Negative 3 equals 9 raised to the 1/2. Negative 3 equals 3. No, it does not. No, it does not. So 3 does not work. Your final answer is x equals 4. X equals 4. Okay. If you get 2 answers, you always got to check. These ones are for you to try by yourself. Try these ones by yourself. And since I'm going a little over time, I'm just going to go ahead and give you the answers. This one is x equals 22. This one is x equals 5. And this one is x equals 3. Okay? I'll go ahead and do this one, just because I'll feel bad if I decide to assign it for a homework quiz and I didn't actually work it out on the video. So we've got, or a warm-up quiz rather. So we've got 3 times x plus 6 raised to the 1/2 equals 9. So what I can do in this case is go ahead and get rid of this 3. So I'll divide both sides by 3. And this becomes x plus 6 raised to the 1/2 equals 3. 9 divided by 3 is 3. Now, to get rid of this 1/2, I can multiply both sides, or not multiply, I can raise both sides to the power of 2. Boom. 1/2 times 2 is 1. So that just gets rid of that. That frees this up. X plus 6 equals 3 squared, which is 9. I'm going to subtract 6 from both sides, and I get x equals 3. Okay. Radical inequalities. Radical inequalities. You know we had to throw in inequalities at the end of this. So, we've got the square root of 2x plus 4 is less than or equal to 4. What I'm going to do first is show you what this looks like on a calculator. And then we will solve it algebraically. 2x plus 4, 4. Oh, I'm zoomed. Ah, come on, come on, come on. So that's your square root of x plus 4, or 2x plus 4, and that is your 4. Okay, and it wants to know where this radical function, this curvy one, it wants to know where that is less than 4. So where do you know that it's going to be on this interval between here and where they intersect? Okay, so let's figure this out algebraically. First thing that we're going to do is solve for this x. So we've got 2x plus 4 is less than or equal to 4. Let's get rid of this radical. We'll square both sides, so we're squaring both sides. And we get 2x plus 4 is less than or equal to 4 squared, which is 16. Subtract 4 from both sides, I get 2x is less than or equal to 16 minus 4, which is 12. Divide both sides by 2, x equals 6. This represents the area at which the two graphs intersect. Okay? there is also an area where this graph just sort of, it springs up. If you remember from last lesson, radical equations, they cannot be negative, okay? As you see from here, there are no values of x that are to the left of this starting point right here. So we got to figure out where that starting point is. And so what we want to do is take our radicand, what is beneath the radical, which is, in this case, 2x plus 4, and we're going to set that, we are going to set that greater than 0, because the values cannot be less than 0. So we're going to set that greater than or equal to 0, because we cannot have a negative radicand. It becomes an imaginary number. So let's solve. Subtract 4 from both sides. We get 2x is greater than or equal to negative 4. Divide both sides by 2, and we get x is greater than or equal to negative 2. So now, oops, that's supposed to be that. So now we have this interval, right? We have x is less than or equal to 6, but x is greater than or equal to negative 2. So we can write this as negative 2 is less than or equal to x, right? I'm just flipping this around. And then x is less than or equal to 6. And that is your final answer. You can also write this as in notation form, negative 2 to 6 in brackets because it's inclusive. And if you look back at your graph, you'll see that that's true. From negative 2 to 6, the graph of the square root of 2x plus 4 is less than or equal to this graph up here of 4. Cool, okay. Try these ones by yourself, algebraically. Okay, now I'll go ahead and do these. So I'm going to go ahead and subtract 2 from both sides, and we get the square root of x minus 3 is less than or equal to 5 minus 2, which is 3. Then I'm going to square both sides, and we get x minus 3 is less than or equal to 9. Add 3 to both sides, and we get x is less than or equal to 12. Now I need to take my radicand and set it to being greater than 0. So I have x minus 3 is greater than or equal to 0. X is greater than or equal to 3. So now I have this interval of, let's see, is this right? Yes. So we've got this interval of from 3 to 12. Okay? And that is your final answer. And you can look at the graph to make sure that that's right. Okay, and then the next one, we've got the cube root. Oh, this is different. We've got the cube root of x plus 2 is greater than or equal to 1. So to get rid of this cube root, I'm going to cube both sides. Okay? So that gets rid of that. We have x plus 2 is greater than or equal to 1 cubed is 1. Subtract 2 from both sides, and we get x is greater than or equal to 1. Now, do I need to set this radicand so that it is greater than 0? If it's a cube root, can you take the cube root of negative numbers? Yes, you can. The cube root of negative 8 is negative 2. So you can take the cube root of negative numbers and positive numbers. So this is simply your answer. There's no other critical point and your answer is x is greater than or equal to 1, and I'll show you on the graph. I'm taking the cube root of x plus 2, and I'm graphing 1. No, why did I, math, cube root of x plus 2, and also 1. So this is my graph of the cube root of x plus 1, and that is the graph of 1, or sorry, x plus 2 and 1. And you'll notice that it wants to know where it's greater than 1, and it's from -1 all the way on. So, there you go. Okay. Final problem. Final problem. The speed s in miles per hour that a car is traveling when it goes into a skid can be estimated by using the formula s equals the square root of 30 FD, where F is the coefficient of friction. I don't know if any of you are in physics, but you're going to be using the coefficient of friction of a lot of things. And D is the length of that skid marks in feet. So it looks like, according to the picture here, this guy, we've got a skid mark of 120 feet. It says, after an accident, a driver claims to have been traveling the speed limit of 45 miles per hour. The coefficient of friction under the accident conditions was 0.7. Is the driver telling the truth? Okay, so it wants to figure out, we're going to be detectives and see if we need to give this guy a ticket or not, okay? So, I'm going to move this up, all right? And we've got our formula, S equals the square root of 30 FD. We know what the speed is that he says he was going. He says he was going 45. I'm assuming that's what the speed limit was because he doesn't want to get in trouble. And we've got the square root of 30 times the coefficient of friction, F. Coefficient of friction at this particular road was 0.7, okay? And we're trying to figure out D, the distance of his skid marks. Okay, so let's go ahead and solve this. What we're going to do is square both sides to get rid of this radical. If you want, you can try this one by yourself. And we've got 45 squared is equal to 30 times 0.7 times D. Okay, so I'm going to go ahead and do this math, and then we'll figure out what we've got. So we've got 45 squared, which is 2,025. And we've got 30 times 0.7. 30 times 0.7 is 21 times D. If we're solving for D, we're going to divide both sides by 21. Divide by 21. I don't know what's wrong with my, sorry about that. And we have a distance of 96.4, and this is in feet. Okay, so if he was going 45 miles an hour, his skid marks would have been 96 feet. But as we can see, they were 120 feet. So this guy is a liar. He's probably going 60. Okay, you don't have to do the quiz. That's it. Good job. See you in class.